Alright, let me test the screen. Let's see if this is going on. Let me see. Alright, I think it's working. Let me check the audio here. Alright. I think it's working. Okay, we left off last time with this train example. So what I'm going to do is I'm going to go back to that and alter the problem statement a little bit. Let's see. Okay. Here we go. And for some bizarre reason, there we go. Actually, that's probably fine. Okay, let's see what I can do about blocking off a portion of the screen. Moving that over. Now let's see what I'm looking at. Bring that back up. Okay. So let's see what we're seeing here. I wish that might make it a little bit better. Okay, so we're going to change the problem statement a little bit. Oh, you can't see it. Okay, so with the train, this one's going to the right. This one's coming to the left. We have a new equation. Now we're going to say, and we're going to go through a series of cases here. We're going to say this, say 0.2, 0.5, and all the way up to 1. And we're going to look at the implications of some of these choices. So we have to do this. Now let me make sure the screen, for some reason this thing is off. Let's see. Okay, well there's enough visual there. So this one going 1.5 to the right, to the left, this one's going 3 meters per second. Because I think you're clipped off on part of this. This one was a mass of 20 megagrams. This one is 15 megagrams. and they collide. They collide, and we're going to find out what the implications are on both of this. Again, we're talking about the system. During the collision, there is these two coming together, but there's nothing else pushing either one of these during the collision. During the collision, they're pushing against each other and pushing back. So, what we have, and these are listed as A and B. A final plus M, B final, B final is equal to M, A initial, VA initial, M, B initial, VB initial. Now, if I start filling this in, again, I've got to go down this concept of what is positive and what is negative. These are vector equations as per se, so you have to have a positive and negative direction there. Mass of A, I'm just going to list them as 20 because the e to the 6th can be canceled out on all the terms. So I'm just going to list them as 20. 20, VA final, I don't know. B, this one is 15, VB final. MA initial, it doesn't change mass. Initial, okay, so I'll go in here, VA initial is plus 3. VB initial is minus 1.5. Here's your problem. You look at this equation and you have two unknowns. If you look at the problem statement originally, he told you the final velocity of one of these. Often you don't know that. What you do know is, for example, you can look, and we'll look in a minute if I get a few minutes. I'll look at a golf. This is very prominent in the world of golf, or any other thing that has an impact. So, how do we deal with that? You know, the two unknowns. Well, you got a new equation. So what I'm going to do, I'm going to take this and move to the other side, and I'm going to take these two and list them right over here. So, what I'm going to do, take that equation, take the top, VB final minus VA final equal to this moved over to be E times VA initial minus VB initial. Now, if you want to have things line up, you can, well, I've got this term here and this term here. I'll just go with it as it is right now. Turns out I do know this one, VA initial, is simply 3. I do know VB initial going this way is essentially minus 1.5. So now I'm going to, in a minute I'm going to put in values of 0, 0.2, and 0.5, but right now I'm going to carry this as an E. So if I want to remove things out of here, one of the things I could do is, you can see there's this. So if I multiply this times 20, and this side times 20, then I get this times 20 minus that. These terms cancel. I'm simply adding these two equations, and I'm going to put a third one below it. So I got 20 and then 15. That gives me 35 VBO equal to. Now, let me take a minute here and do all this. So I'll hit my calculator off screen here. That would be Uh, Should be, this one and this one go together, it'd be 37.5. I get 20 times all this. $90. And so now I'm going to go ahead and remove this. Let's make sure in a second that I've got this correct. Okay, 35 will be 37.5 plus 90E. Now, what I'm going to do now is, I've got two choices. I can take this one and stick it in here and solve for VA. So what I'm going to do is I'm going to do that. And I'm going to list them both here. But when I put them back in here, I'm going to have VB final put right here. And so what I'm going to have is 20 VA final. Or maybe I'll do these just one, I'll make a table. Instead of doing them that way, I'll make a little table of them. I'm going to say E is 0. I had 0.2, 0.5, and 1. And let's watch what happens here. VB final and VA final. Then you may see something that is very interesting here. Let's start with 0. And I guess I'll have to put this out. And so if I put in 0 for E right here, I get 37.5 over 35. Give me a second. Do about 1.07. And I'm going to carry extra digits, and maybe you'll see why in a minute. Now, I do need to craft up this. So I do need to craft this up. So here's what I'm going to do. I'm going to take this, move it to that side. This is still 37. So this and this is 37. I got to move this one over. And I got to divide it by 20. So now, if I take this and put it in here, it's still left in my calculator, so I can carry all the digits and multiply it times 15. I think I've made a mistake here. However, I think I haven't. I think it's just a typo. So, notice something interesting here. I didn't make a mistake, by the way. These are both trains are going to the right, the final situation. They're both stuck together. For E is equal to 1, they are stuck together. So this is kind of unique. These are two special cases, both ends of this spectrum. For E is equal to 0, you should always get the same velocity out of both objects. Sorry about that. So now let's put in, okay, so this is E equals 0. Now, let's go ahead and put in E is equal to 0.2. You don't see much difference, but let's just go through this. Okay, hang on. 0.2 times 90 plus 37.5 divided by 35 gives you 1.5857. Now I'm going to take that number, put right in here. And now I get 0.6857. Now, let's fill this out, and 0.5857, 0.6857. Now let's look really close at these and look at the dynamics of what happened. What has happened, the two trains have hit. The first example, there was enough mass here and enough speed on this left side, so it overrode it. They stuck together and they moved to the right. If they don't stick together, there is no way on earth that this speed can be greater than that speed. The train cannot go through each other. So the left one always either goes equal to the speed of the right one or smaller. So in fact, here's A, here's B. Okay, look at B, it's moving to the right at 1.58. A is moving to the right a little slower. This one cannot outrun that one. So when they hit, they basically are either going to stick, come apart, or they're going to stick, move to the right, or they're going to bounce off each other. But the one on the right will go faster to the right. That's why this one will always be larger. I'm going to just skip this one for now. I'll go ahead and do it. Here, I've got this down, so what I'll do, 0.5. We'll go through, figure this out for 0.5. Now it's 0.5. 2.357. Shoot. All right, let me do that again because I had all the digits. Clear. Okay, 0.5 times 90. Okay, so I've got all the digits. I'm going to multiply times 15. .107. 10714. And this one's 2.357. So in the second case, this one's going a little slower. This is going a little faster. Now the last one's a special case, and we'll see why in a minute. It's pretty obvious why the first one is a special case. Okay. So if we put in 1 here, calculate this out, we get I may have, okay, 3.642. And this is 0.85714. So for this case, 85714 and 1.0714. Now, let's look at the side issue here. Okay, so you can see what happens. Oh, wait a minute. I copied it down wrong. This one goes here. This one goes here. So you can rewind the video and do things to it to look at what I did. Now I'm going to take this place and I'm going to look at something, what is special about this one. So we'll go through this. Hopefully I didn't make a mistake. If I did, I'll log and redo the thing later. So what is special about this one? Let's go back to energy. Okay, the two objects had a state initial and a state final. Let's look at the initial energy. All you had is 1/2 MA VA initial squared plus 1/2 MB VB initial squared. So let's do the initial energy. Okay, so here, I'll take A. It was 20, and again, I'm dropping the 10 to the 6th here. 3 squared plus 1/2, 15. Now, it doesn't matter whether this is going left or right. So if I look at the energy at state 1, you'll find something interesting. 20, 2. This will give you 90 plus this one's 90. $16.875. So the initial energy is 106.875. And again, I'm taking off the megagram. Let's look at the final. Okay, so I have 20 plus 1/2. Okay, so this is the initial. 1/2, 15 squared. Now, I've got 4 different groups, 4 different situations. I'm going to start looking at this one. Okay, this one is B moving to the right, which is 3.642. This one is 0.85714. Now, I have not carried all the digits here, so if I'm off by a small portion, that's okay. .85714. I'll have to turn it sideways and square it times 10, 7.34688. I think I did that right. 3.642 squared times 15 divided by 2, 99.48123. Now, of course, there's a few digits there. I'll add these two together. Lo and behold. Now, here, here's a round off. The case in point, for E is equal to 1, there is no energy loss. This means it's a totally elastic, no energy loss in this one. Now, is that the case here? a look at it. I don't have another marker, but I'm gonna erase it because you can rewind it, look at it. I'm gonna go through these one at a time. In fact, I'm gonna put e-file here. I'll say e-file. 106.8. I'll leave it, I'll just truncate it at that first digit because all of these are gonna have truncations in here, and I'm squaring them, so they're gonna get worse. So let's look at the second one. Okay. The A. Okay, so here, let me try to keep up with this. This is A, and this is B. This will help me get through this. So look at A, 0.10714. Look at B, 2.357. .357 squared times 7.5. This becomes 41.67. 0.1714 squared times 10. Considerable loss of energy. Notice what happens. The energy state here, considerably lower than the initial energy state. This, E is equal to 1, is a special case in which it's completely elastic. Now let's just go ahead and go straight on to here and see what the worst case is. Now you can come back and plot energy versus E and do several of these, but I'm not going to do that right now. Okay, let's go back and look at the worst case. Is the energy here lower than this one? Now, this one that's the same number in both. But 8.61. And 11.47. Add those together. Oops. In fact, it is lower. So in fact, I'm not sure. This would be the energy. This would be E. You go from 1, you go to 0. You would be down here at the lowest, and you'd be up here at the highest. How it goes here, I don't know, but this is what you're going to get, one of these curves. We can spend the time and look at this. I have a feeling that it drops off rather quickly. So again, okay, now, I promised I would show you something to do with golf. I'm going to do that, and then I'm going to leave. Okay, first, let me head back to see. Okay. So you are back on the screen, I believe. Yeah. Let's do this real quick. Wrong one. Okay, so if you go look at coefficient restitution, you'll find it on a Wikipedia site. And he claims it's a relative velocity after collision, relative velocity before collision, and that's really true. But the equations, well, he doesn't do. He has several coefficient restitution things down here. But here, let's do this. Let's see if I can do this. Okay, so you'll see it says many golf fans were shocked to learn that drivers were this guy's driver ruled illegal. It's bouncing around. Ahead of the British Open Championships, you get on down, and you will find out there is a rule. They have a maximum coefficient of restitution of 0.83. And I guess if you have too high, it's ruled illegal. And maybe what we'll do is come back and look at the implications of too high, what happens here. And here's a guy, some sort of video. So if you want to look at that, I'd say look at that, but I'm going to draw this to a close.